Let's talk about measures in psychology, scores, what they mean, how to interpret them, and how to interpret differences between them. So let's say you get a score on a test. That's a measure of some psychological property of your knowledge of course content. And you get a grade of 72%. Is that a good grade? How do we interpret and evaluate that? Is 72 a good grade? Well, there's different ways that we could think about that. We could compare your score to the average scores in the distribution. We can think about what the distribution looks like, what's its center, and what's its spread. And you might hope that you get a score that's average or above average. Call that good. So in that context, a 72 is around the center of that distribution, but there are people who did better than that. And there's people that did worse than that. So looking at that distribution, you could say, 72 is pretty average, it's okay. Now, we could set criteria for what a good grade is that are absolute and that don't depend on how many people get that grade and whether that's average and whether your score is below average or above average. We can say, as it says in the undergraduate calendar, that a grade of 50 is not good enough. It's marginal. It's a pass, but we don't like that too much. We could say the grades in the 60s, and we do, are satisfactory, and the grades in the 70s are good, and the grades in the 80s or above are excellent. And according to that criterion-based approach, 72 is a good grade because any score that ranges between 70 and 79 is a good grade. And it doesn't matter what the average grade is in the class. Right? As long as you pass the 70 threshold, then you have a good grade. Those are two different ways you can interpret the scores. So you can interpret it relative to other people's performance, or you could interpret it relative to certain thresholds that we have defined as being good or bad. Now, let's say you take a driving test. That is not a norm-based test. In order to pass your driving test, you have to earn so many points. Okay, and if you've reached 30 points and you haven't made any fatal mistakes, then you pass your driving test. And it doesn't matter whether most people fail the test or most people pass the test. What you have to do is earn that minimum score and not do anything dangerously foolish, and you can pass your driving test. So that's an example of a criterion-based test. There are other tests in psychology that are norm-based tests, and a famous example is the IQ test. So if you have an IQ of 100, that doesn't really mean much about your specific cognitive abilities. It just means that your cognitive powers of intelligence are average, are like most people. In a score of 120 isn't about how you answered the questions on the IQ test. It just means that your score is higher than average. And in fact, what an IQ of 100 means has changed over the years. Started giving people IQ tests over 100 years ago. And since then, we have better education, better universal public education. We have better nutrition. We have better standard of living. And so people's intelligence, their practical intelligence, their practical cognitive abilities have actually been increasing over the last 100 years. So what an IQ of 100 means in terms of practical ability has changed. 100 today does not mean what an IQ of 100 did 80 years ago in terms of the absolute practical skills that are associated with that. What it means is that it's an average score. Okay, but the average, the particular abilities that are associated with the average score have changed over time. We can ask what makes a good psychometric measure. Okay, what makes a question a good question? Let's say I want to measure your well-being. It's a lot harder to measure that than to measure the weight of a pack of salt. I'm going to have to use a rating scale, say from 0 to 10, and I have to think about, well, what does 0 mean on that scale, and what does 10 mean on that scale? Where do you think you fall on it? Oh, you said 8. That's a sort of subjective measure. And what 8 means on a well-being scale isn't the same as what 8 grams means. It's not the same kind of a unit. So in psychology, we have to think about the quality of our measures. And we often think of that in terms of validity and reliability. Validity is about whether the measure actually measures what it's supposed to measure. If I want to measure your well-being, how satisfied are you with your life today is a reasonable question. Okay, that has content validity or face validity. And that measure might even have some predictive validity. Let's say you give me a high well-being score, your well-being is 10. Well, then I would expect that you'd also get a high score on some happiness measure. You'd also be showing me other good outcomes. It could predict something. Now, let's say I want to measure your well-being, so I ask you your favorite color. That is not a valid measure of well-being. It's not. The question doesn't tap the construct of interest. What is your favorite color doesn't measure well-being. And it might not predict anything either. Let's say that you had a high score on well-being. I expect that that predicts something. Maybe it predicts longer life expectancy. Maybe it predicts the amount of joy that you feel. If you say your favorite color is blue, does it predict any of those other scores? Probably not. Now, sometimes there's bias in tests such that they're not valid or reliable for certain groups. IQ tests can be culturally specific. I have seen an IQ test where one of the questions was, where does the Pope live? And the response is where London, Paris, Rome, and Vatican City. And the correct answer, Vatican City, is obvious to anyone that is familiar with Catholicism, that has some formal education in history. But let's say we went and asked that question to hunter-gatherers in some remote part of the world. Would that question validly measure their intelligence? Probably not, because maybe they've never heard that information. And so that would be a biased test. It would not be valid or not be reliable in that other group. What do I mean by reliability? Reliability is the extent to which a test yields consistent results. And a test can be reliably wrong. So let's say that I measure the exact same thing. If I repeat that measurement, I should keep getting the same results. So let's say that you are 5'4" and I measure you with a measuring tape. I do that 2 or 3 times. I should keep getting the same result of 5'4", assuming that your height hasn't changed, and of course it wouldn't. Now let's think of the reliability of measures in psychology, like your well-being score of 8. I asked the class the other day to tell me what your well-being score was. And one student raised her hand and she said 8. And then she said, no, wait, actually 7. She changed her answer. Same question about the same subject, same scale, and she went from 8 to 7 at a moment's notice, and I'm not sure why. So obviously, my 1 to 10 scale of well-being is a lot less reliable than a measuring tape. And a measuring tape is more reliable than a bathroom scale. Because let's say you weigh what you weigh. Every time you get on your bathroom scale, you get a slightly different reading, right? But your weight hasn't changed. It fluctuates a bit. And this is why you get on and off your scale repeatedly until it settles on a number that you like. Because it's relatively less reliable than, let's say, a tape measure. You're not going to have a tape measure that says, oh, you're 5'6" now, now you're 5'4", now you're 5. No, that's a matter of reliability. If a test yields the same result, given that the underlying condition hasn't changed, over and over again, every time I measure you with a measuring tape, you're 5'4", then I would say that this measure has high test-retest reliability. It's a bit harder to assess that with these subjective psychological traits, because let's say that the student gave a well-being score of 8, and then she changed it to 7. Has her well-being really remained the same, or did something happen, maybe something in her body or in her mind, that really made her well-being decrease? She thought about her ex-boyfriend. Ooh, that made her feel worse. Okay? If I see a difference in a score, is it because the measure is unreliable, or is it because the underlying construct that I'm measuring has actually changed? Assuming it hasn't changed, a really reliable measure has high test-retest reliability. If we're taking measures, we want to give everyone the same measure the same way. If I ask you to rate your well-being from 0 to 10, I shouldn't be changing the standards of what a 0 means and what a 10 means between different people or from one delivery of that measure to another. That's a matter of standardization, and it's one way that we get experimental control in psychology. So let's say we find some difference between groups. We find a difference in the average well-being score between the people who are in therapy group and the people who are in the control group that don't get the therapy. There are a lot of questions we could ask about that difference. Well, is it reliable? Do you trust the measures that I used? We can ask, is that difference that we observe between the two groups one that we can generalize to the population? Okay. We could ask if it's large enough to matter. And then let's say we find a difference. Well, what are you going to do about that difference? Is that going to inform policy decisions? That's a political question. There is a classification in psychology for the absolute size of a difference. Okay? Is this a small difference, or is this a large difference? And we express that with different types of measures. We've talked about Pearson's R, the correlation coefficient. And the correlation coefficient ranges in absolute value from 0 to 1. That can be a positive relationship. So positive 1 says that as your score increases on X, then your score also increases on Y. Here's positive 1. Or we could have a negative relationship. As your score increases on X, score on Y seems to decrease. Let's not worry about whether it's positive or negative in direction. We just want to focus on the absolute value. Well, 1, whether it's positive 1 or negative 1, is a very strong relationship. You have a very strong ability to predict your score on Y from the score on X. All the points fall on that imaginary regression line. The prediction is perfect. Now, let's say that there's more error. And what I mean by error is that our regression line predicts that if we have a score over here on X, it should fall right on this line for Y. And that's certainly happening when the correlation is 1, but when it's 0.8, you can see there's a bit more scatter. And when it falls to 0.3, there's even more scatter. And when it falls to 0, it's just all scatter. And the points are not falling on the line. A correlation of 0.3, whether it's positive 0.3 or negative 0.3, is a moderate effect size. And you know what? Most effects in psychology aren't in the moderate range. Right? Many of them are in the trivial to small range. And let me give you a better sense of what those effect sizes mean. So with a very small effect size, there's little or no noticeable difference. If I were to look at this difference between groups in the world, I would be so hard-pressed to actually see it. So an example might be a difference in the average heights of girls aged 15 and 15 and a half. Can hardly see that. On the other end of the scale, you have a large difference. And in that case, the difference is grossly perceptible. The difference in the average heights of 10 or 18-year-old girls is really easy to see. You can express that in a value called Cohen's d. They're setting the threshold for a large effect at 0.8. An effect you've likely noticed that you can see when you look around the room is that there's a difference in height between men and women, such that men are usually taller than women. You can observe that. The value of that in terms of Cohen's d is 1.7. Most differences we measure in psychology, that's a physical, not a psychological differences, are much, much smaller than that. Now let's get at the question of statistical significance. That's a really tricky concept for most students. Statistical significance ultimately refers to whether a result from a sample can be generalized to a population. So let's say that I measure well-being in 2 groups. And there's a treatment group who gets the therapy, and there's a control group that doesn't get the therapy. And I find that the average well-being in the therapy group is an 8, and the average well-being score in the control group is a 7. Well, the average well-being is higher in the treatment group than in the control group. Is that difference statistically significant? That question refers to whether that difference exceeds the fluctuation that we would expect in these subjective, unreliable measures due to chance alone. And when psychologists analyze that data, they calculate some tests, and one of them is a test of the p-value. And the p-value tells you the probability of whether a result this extreme or more extreme is a result of chance alone. Let's go and look at a normal distribution. The normal distribution says that most scores, whether it's a score on a trait or a difference score, fall around the mean. Okay, about 68% of them fall within one standard deviation of the mean. The standard deviation is a measure of the average deviation of a score from the mean in a sample. Okay? And according to the normal distribution, the laws of the normal distribution, we'd expect that 68% fall within one standard deviation. And then, as scores get more and more extreme, more and more different from the mean, the frequencies of seeing such scores, either very high scores or very low scores, drops. Okay? And so we're more likely to see average scores and much less likely to see really extreme, really high scores, or to see really large differences. Let's say that in truth, this therapy does not work. What that means that if we drew many, many samples, infinite samples from the population, and compared the average well-being in the treatment group and the control group, there'd be an average difference of 0. Say we keep doing those studies, we keep drawing those samples and making that comparison, and there's no difference in reality. Well, we'd expect that we'd be drawing a lot of comparisons where the difference score is 0. We wouldn't always be seeing that. Sometimes, because of random error, we would see differences. Sometimes the treatment group would have higher well-being score than the control group. And equally, sometimes the control group would seem to have a higher score than the treatment group. However, we shouldn't be too likely to see results like that. Those extreme scores, we shouldn't be seeing too many of them if the true difference is 0. Psychologists, when they're doing studies, start with a null hypothesis. The null hypothesis is that there's no difference between these groups, and we're expecting to see an average difference between the group of 0. Let's say we find a really large difference. It's way out there on the tails. Psychologists have set a criterion score. That criterion value is usually 5%. It isn't always, but let's go with 5%. And if a score is so extreme that there is a less than 5% chance that we saw this effect, given that the null hypothesis is true, given that there's no real difference between the groups, what the scientists will do is they'll reject the null hypothesis. They'll say, this is so extreme that, in fact, I don't think that there is no real difference between these groups. Okay? Because seeing this large difference is so unlikely to have happened by chance. You know what? I think there is a true difference between these groups. I reject the null hypothesis. Okay? And I go with the alternative hypothesis that treatment works and that people in the treatment group have a higher average well-being score than treatment in the control group. That's what it means to have a statistically significant result. The difference was so extreme that we can't really accept the conclusion that there's no true difference between the populations and that our results is just because of a fluke that's to do with our samples. So let's say you do find a statistically significant difference. Well, does that matter? Because you could have a statistically significant difference that is really small. It's a reliable difference. We believe this is a real difference between the groups, but if it's really small, it doesn't matter. Well, maybe not. Let's say you have a program and it reduces bullying from 60 to 55%. Does that matter? That's a hard question to answer. Technically, that's a very small difference. And you might say, well, this anti-bullying program costs so much money and took so much class time that it's interfering with their math performance scores, and no, that's not really worth it. Or you might say, well, if we save one life, then it is worth it. So statistical significance gets at the question of, is this difference reliable? Do we believe that it's a real difference and not just some fluke to do with chance? But that doesn't really say whether the difference is important. And what you do with a difference is a political question. So psychology measures differences between people, and that gets political really quickly. Politics is about power. It's about values and what you do on the basis of those values. So let's say that we find group differences in intelligence. Okay? That has happened. What are you going to do with that story? Those who have advocated for eugenics would say, well, you know what? Only the people with the higher scores are allowed to breed, and we will forcibly sterilize everyone else. And that's been a policy decision. There have been policy decisions around immigration saying, okay, we saw that these particular European groups had higher scores on our intelligence tests than these non-European groups, who will restrict immigration from those non-European groups. That happened in the United States. The first IQ tests were developed by Alfred Binet. Okay? Alfred Binet had a very different way of thinking about those differences than Francis Galton did. Francis Galton, father of eugenics, he would have said, all right, if we detect that these particular groups have lower scores, they shouldn't reproduce. They don't let them in. That's one way to think about a difference. Well, Binet used IQ tests in order to identify students who might benefit from remedial education in the classroom. So he used it for exclusion versus inclusion. So those are completely different things to do about an observed difference that ultimately get back to politics and to power. Thank you for your attention.